Okay, problem number 2. A particular algebra text has a total of 1,382 pages, which is broken into 2 parts. The second part of the book has 64 more pages than the first part. How many pages are in each part of the book? So I'm going to let x equal the number of pages in the first part and y be the number of pages, and I can use ditto marks, in the second part. Now, the first number is important to us because we know all the pages in the book add up to 1,382. So x plus y equals 1,382. Now, the second part has 64 more pages than the first part. Now, that one's going to be a little bit harder to set up because it's not just a straight is statement that we'll see in some of the later problems. So in this case, what I'm going to do, I'll put my number 2 there, is I'm going to set it up. I've got to figure out, where the 64 is going to go. So this is the way I usually do it. I set the 2 equal to each other, which I know is not true because I know the second part has 64 more than the first part. So if this one has 64 more than the first part, to be equal to that, I would have to take 64 away from the bigger one. Or I could have taken the x and added 64 to it to get to get to the smaller one to get the bigger one, because we knew that the second part had more pages. So I'm going to use this one. To me, that was just the easiest one. I need to get it in standard form, so I'm going to subtract the y from both sides, and I get x minus y equals negative 64. And then that's my equation that I'm going to use when I get ready to do. So now I'm ready to put it in my calculator, and I would put into the systems program, I would put 1 for my A, B, C, D, E, F. I would put 1, 1, 1, 3, 8, 2, and 1, negative 1, negative 64. And you will get in that, you will get that 59, and it will give you that y is 23. So, and if you check it, you can see that 659 plus 63 is 64 is 723. And if I add these two together, I do get 1,382. So my sentence will be the first part of the book has 659 pages, and second part has 723 pages. Number 3. Dennis mowed his next-door neighbor's lawn for a handful of dimes and nickels, 80 coins in all. Upon completing the job, he counted out the coins, and it came to $6.60. How many of each coin did he earn? Remember, we need to let our variables represent numbers, so I'm going to let D be the number of dimes, and I'm going to let, what's my other coin? N be the number of nickels. Now, you've got two kinds of equations. You have the total number of coins, which is not their value, but how many you have. And so I have a total of 80 coins. And then the value of each of those added together is going to be $6.60. Well, the value of one dime is 10 cents, and I have D of them, whether I have 2 of them for 20 cents, 8 of them for 80 cents. So I'm going to take 10 cents times each dime, ever how many I have, that will be my value of my dimes. And then a nickel is going to be 0.05 times my number of nickels. And when I add that money plus this money, I will get $6.60. Now, when you plug that into your systems program, now, all of these can be done by substitution, elimination. You can use any method you want to, and especially on the ACT, you want to use the method that's faster for you. This one could easily be set up with elimination. You'd have to deal with decimals, but substitution will also work. So when I plug in the 180 and the 0.10 and the 0.05 and the 6.60 for my coefficients of my equations, then I will get the final result of, okay, there will be 52 dimes. D is 52. I'll just put that up here. And 28 nickels. And you can check that because 52 and 28 do add to 80. And 52 dimes would be $5.20. And 28 nickels would be $1.40. And then you'd have a total of $6.60. So my statement, I'm going to say Dennis has 52 dimes and 28 nickels. Number 4. The perimeter of a rectangular garden is 62 feet. The length is 1 foot more than twice the width. Find the dimensions of the garden. Well, dimensions simply mean the length and width. So I've got length and I've got width. So I'm going to and because those are numbers, I can just say L equals length and W equals width. And the first sentence says the perimeter is 62. Well, we know the perimeter of anything is the sum of all the sides. So L plus L is 2L, plus W is 2W. So 2L plus 2W equals 62. Now, the length is, and we love the word is because this is going to just be translated right into words, from words into algebra. So the length, that's my L. Is my equals 1 foot more than. That simply means 1 plus, and then twice the width is 2W. Let's get it in standard form. And I get L minus 2W equals 1. So in my calculator, I'm going to put A, B, C, D, E, F, 2, 2, 62, 1, negative 2, 1, and it will give me a length of 21 feet. Is that my unit? Yes. And the width is 10 feet. So the dimensions are 21 feet. You can use the word by, you can use the big X, and I'm just going to put by 10 feet. My sentences don't have to be real complicated. Number 5. Number 5, 2 angles are supplementary. The larger angle is 48 degrees more than 10 times the smaller angle. Find the measure of each angle. So I'm going to let X equal the measure, has to be measure for a number, of the larger angle. And I'm going to let Y equal the measure of the smaller angle. Now that's where supplementary helps us out, because if you remember, supplementary means the two measures add up to 180. And then our sentence here gives us a straight equation very similar to number 4. The larger angle, which is X, is, that's your equals, 48 more than, so that's plus 10 times the smaller angle, 10Y. Let's put that in standard form if we're going to use our program. So we've got X minus 10Y equals 48. Okay, now I can type into my program 1, 1, 180, 1, negative 10, 48, and it gives me that X is, I can actually put it up here, 168 degrees, and the smaller one is 12 degrees. So I can say the measures of the two angles are 168 degrees and 12 degrees.